For the last part of this lab, it's about RL circuits and the differentiation. So the output is across the inductor and input is connected directly to the resistor. And the resistor and the inductor are in series. So we only have one inductor, one value, which is the 2.7 millihenry. And I use the same resistor values I used in the previous part, the integration part. So same tau, same time constant, and here's the circuit. So the input, this is the first circuit, the 4.7K, this is the 1.5K, this is the 560 ohm. Input from the function generator is connected to the resistor. So the input is connected to the resistor. Resistor is in series with the inductor to the ground. Output is across the inductor. Now to set the function generator, so it's a square wave and the amplitude is 2 peak to peak. The period is 12 times the expected tau. So for this circuit, it's 2.7 millihenry divided by 560 ohms, which is the 4.8 microseconds, times 12, 57.8. So the period is 57.8, and here's the output. Just adjust the output, move it a little bit down. And then cursors, X1 should be at the very top, X2 at the very bottom, then read delta y, which is 1.74 multiplied by 0.632 is 1.09. Move x2, cursor x2 until delta y equals 1.09. Delta x is tau, and tau is 4.1 microseconds. There is a huge gap here because the expected tau should be 4.8. Let's do this again. So auto scale. I ruined this. So for this circuit, it's the 560 ohms and the 2.7 millihenry. So the input from the function generator goes to the resistor, and then the other side to the ground. Here's the 10 to 1 probe. Is measuring the output across the inductor. The other side is connected to the ground. Now to set up the function generator, it's a square wave and 2 peak to peak, and the period is 12 times the expected tau, which is 57.8. Now again, here's the output. So with the input, here's the input from the function generator, which is the square wave, and here's the output across the inductor. So we turn channel 1 off, maximize one of these parts because this is a differentiation. Down. maximize it horizontally. Now cursors. Cursor x1, the very top. Cursor x2 at the very bottom. Now read delta y 1.76, multiply it by 0.632, which is 1.1. Now move x2 until delta y equals 1.1. Now delta y is 1.1 and delta x is tau, which is 4.7 microseconds delta x, and the expected tau for this circuit for the 560 ohms and 2.7 millihenry is 4.8 microseconds. Let's try another circuit, which is the 1.5K and the 2.7 millihenry. Back to the breadboard. Inputs to the 1.5K resistor connected to the inductor to the ground. The output is across the inductor. And now to the function generator. So the same as square wave, and the amplitude is 2 peak to peak, and the period is 12 times the expected tau for this circuit, which is for this circuit it's the 1.5K, L is 2.7, so the time constant is L divided by R, which is 1.8 microseconds. 12 times tau is 21.6 microseconds. So 21.6 microseconds. So here's the output. First the auto scale. Turn channel 1 off. And then maximize channel 2. Then use cursors. Cursor x1 at the very top. Cursor x2. And then read delta y, which is 1.68 multiplied by 0.632, 1.06. Now move x2 until delta y equals 1.06. Now delta y is 1.06 and delta x is tau, which is 1.68, and the expected tau for the circuit is 1.8 microseconds.